Abraham, please help me out of the phone. Hello and welcome to another wonderful day for our physics class. I'm going to quickly, I'm already on the platform Tclassified.com, platform we're using to learn. So I'll quickly click on view our courses so that we can get to physics. Can you hear me? Chika, can you hear me? Yeah, so I'm gonna quickly scroll down.
I hear you.
Okay. So this is the physics we are using. Okay, I hope all of us here know that we have barely 1 month to the exam. Barely 1 month to the exam. So, like, you have to put in your best. You have to put in the work. You just have to sacrifice more. You'll be able to write the exams. Please, okay. So you have to just sacrifice this 1 month from now to the 5th of next month. Hence, from then, you guys are going to be writing the exams. So I wish you just sacrifice this 1 month and do very detailed reading. The last week of this month, we are going to just work on past questions. We're going to work on past questions. I expect you to I expect you to do some sacrifice and get ready for your exams, okay? So I'll probably follow the Luashe, how are you? Luashe, are you there?
Yes, I'm fine, sir. Good evening, sir.
Okay, so today we're gonna wonderfully be looking at waves, and we're gonna be looking at a couple of things on the waves. Okay, so what is this wave that we are talking about? What is waves? Okay, waves. A wave is a disturbance which transfers energy from one point to another through a medium with the average position of the particles of the medium remaining constant. So that is the definition of a wave. And let me play this so that you see what a wave looks like. Okay, so have we tried to put, if you have a bowl of water, you have water in a very big pan, then you just drop a stone into the water, you're going to find out that there will be a movement, a sinusoidal movement from the point where the stone hit the water to the rest of the part of the water surrounding it in the basin. Have you ever witnessed something like that? Chika, have you witnessed something like that?
Yes, I have.
Okay, or even if you just put your hand inside water, you're going to see that movement. So there's what we call transfer of energy from the point of contact where you put the hand to the rest of the part. So that movement, we call it sinusoidal movement. And each front in that wave, each front, we call it wave front. Each front in that movement, we call it wave front. So we're going to be looking at that. And that's why we say that a wave is a disturbance. A wave is a disturbance which transfers energy from one point to another through a medium with the average position of the particles of the medium of a given wave. Please always stay there.
Yes, sir. Yes, sir.
Sorry, my somebody called me and I'm using the data from my phone to host this class. Let me see whether I can put myself in airplane mode. Okay, so like I was saying, if you look at this diagram that I have on the screen, you're gonna see a whole lot of some characteristics of a wave. Now, the topmost part of this wave description that you have here is known as the crest, whereas the downmost part is known as the trough. So this is the crest and this is the trough. Now, the distance between one crest to the next successive crest is known as wavelength. You can see, or the distance between one trough to the next trough is known as wavelength. So you can see this is a crest, this is a crest. The distance between this and this is known as a wavelength. So take note. Now, the distance between the crest down to this very line here is known as the altitude. So take note. And a complete circle from here, down here, up here, because here is half a circle and this is half another circle. So take note of these. So these are very, very important aspects of this, and you're supposed to know it before we move over to basic terms and definition, where you get to know what the frequency is, what wavelength, amplitude, and the rest. So the amplitude is the distance from here to here. The wavelength is the distance from here to here. The crest is the topmost part. The trough is the downmost part. Then to get a complete circle, there has to be movement from here, down here, up here, and down here to complete a given circle of revolution. Okay, so let's keep going. So water wave, if a tiny stone, this is what I just explained to us. Oluwase, is this what I just explained to us about water wave? Oluwase, are you there? Okay, so this is what I just explained to us about water wave. I said that if a tiny stone is dropped into water in a bucket or in a swimming pool, there is what we call circular ripples or waves are seen spread out from the point the stone is dropped. The wave energy transferred from one point to the other due to disturbance is defined as a wave motion or wave propagation. Uche, are you there? Can you, Chama, is it clear?
Yes, sir.
Okay, so once if this is a bowl of water, you just drop a stone. Bagam, you're going to see the water will be moving like this out from that point that you drop the stone. So that is what we call wave in a very simple term. That's how you understand it. And you find out that once you drop the stone, this is the way the water is moving. So it's making this sinusoidal movement. And this sinusoidal movement enables you to calculate the crest, which is the upmost part, the trough, which is the downmost part, distance between one crest and the other, wavelength, distance between the upmost crest and the horizontal line, amplitude. And you're going to know more about the frequency and the rest. So take notes. Now we'll talk about phase. If the disturbed particle of the water medium are at the same circumference of the circle formed and are at the same time distance from the point of disturbance, then they are said to be in the same phase. So all the particles that are in, if you have the stone drop here, then you have this movement. So all the particles that are in that same part of the circle, they are said to be in the same phase. Wave from the common circle in which the particles of front. So wavefront is simply the common circle in which the particles of the waves are seen to be in the same phase. Whereas waveform with the head of a ripple tank, you can, okay? You can draw it. That's what I just showed us. Now let's talk about the terms of a wave like frequency, amplitude, period, and wavelength. So frequency is the number of cycles or particle vibration per second. So number of cycles, and I told you what a complete circle is. I told you that a complete circle is, if you're starting from here, then you have to, this is half a circle, this is another half a circle. So this is a complete circle, movement from here, up here, then down here. Or movement from here, up here, down here to this point. So that is what's a complete circle. So any number of complete circle that is done per seconds is known as the frequency. Take note. So frequency is the number of cycles or particle vibration per second. Per second. The SI unit for frequency is hertz. So take note, hertz, that's the SI unit. And because you're going to be asked which of the following is the SI unit of frequency. I think I've seen that in one of the JAMB questions. So there are also other higher units like kilohertz, megahertz, and the rest. Now we'll talk about amplitude. The amplitude of a vibration is the maximum distance of displacement of the vibrating particle from their position of rest. So what is the maximum distance? This is the position of rest. This horizontal here is the position of rest. So the maximum distance is the distance from here to the crest, because I told you the crest is the upmost part. So the distance from here to the crest is known as the maximum distance from the rest point, and that is amplitude, and that is this point represented as A. Okay, let's keep going. Now we'll talk about period. What is period? The period is the time taken to complete one cycle of vibration or oscillation. So what is the time that is taken to complete the cycle? And I told you a complete cycle is from here, up here, down here, then up here. So this is half a circle. This is another half a circle. So two half a circle gives you one circle. So what is the time it has taken to go from here, down here, and then up here, here? So that time is known as the period, time to complete one cycle. So take note, the SI unit is in seconds, okay? Now wavelength, A is the wavelength is the distance between successive crests. I've told you that, or successive troughs. So these are successive crests. This is a crest here, this is another crest. So the distance between these two is known as wavelength, or the distance between successive troughs. So take note of that. These are terms that will always come out in one way or the other. Then we have wave speed. The wave speed is defined as the distance covered by wave per second. So take note of that. Wave speed is distance covered by wave per second. Okay. So we are going to look at types of waves. This formula, they are not very clear, so I'm going to open it up in the video later and show you. But before that, let's go to types of waves. We have so we have what we call electromagnetic waves, and they are waves of high frequency. Examples are, we have the radio waves, you have the infrared, you have the light waves, you have the UV waves, you have the X-ray, and other ones. Then you also have classification into longitudinal and transverse waves. A transverse wave is a wave which travels in a direction perpendicular to the direction of vibration of the medium. A very good example of transverse wave is the water wave, light wave, and waves on a plug spring. Whereas a longitudinal wave is a wave in which the direction of the vibration of the medium is the same as the direction in which the wave travels. We also have a stationary wave, which are waves that are called when two interfering waves of the same amplitude and frequency traveling in opposite direction. Such waves are obtained when incident waves are reflected back along incident direction. Okay. Okay, we actually have a quiz for this, so please, you guys should make sure you try the quiz before we move to the calculation. Good. So let's look at the formula for this wave so that you can understand it. The one that is written there is not very clear, so I'm gonna lay this out. Okay, so let's look at the various formulas that we can see in wave. Number one is velocity of the wave, which is the wavelength over the period, and frequency is 1 over period, and V you can make. Okay, let me put this very well so that it's clear. Okay, so V is also equal to F frequency lambda. So take note of these formulas. Where V is wave speed, okay. F is frequency, lambda is wavelength. So this is the general equation of wave. A equal to A, where Y equal to A, where A is the amplitude, sine 2 pi ft minus 2 pi x all over lambda, okay, which can also be put in this form. Y equal to A sine 2 pi over lambda Vt minus x, where Y is equal to vertical component of the wave, A is equal to amplitude, x is the horizontal component. Then we have an equation here. The equation of wave is given as this, where x and y are in meters and t are in seconds. What is the velocity of the wave with the given solution? Okay. Okay. Okay, so I'm going to ask us some questions, then we're going to try out this very problem in wave. So I'm going to ask everybody question now. Let's see our understanding of what wave is. And so let's start with Chika. Chika, what do you understand by wave?
You
With an
understand that
example.
the disturbance.
Okay.
And there are two major types of waves.
Okay.
That is the transverse and the longitudinal.
So, Oluwaseyi, can you explain some of the terms that could be used in explaining a wave?
Phase. A phase, if phases are particles which are at the same vertical distance from the position of rest. Then amplitude. Amplitude is the maximum displacement of a particle from its rest position. We also have wavelengths, and wavelength is the distance between two successive crests or successive throws. And then we have frequency. Frequency is the number of complete vibrations or cycles that a particle makes in 1 second. And we have period. Period is the time taken by a wave particle to make one complete oscillation.
Good. Thomas, can you give us some examples of the electromagnetic wave?
Examples of electromagnetic waves. We have light waves, radio waves, light wave, infrared wave, X-ray, ultraviolet ray, and so on.
Okay. So, who else is on the call? Adekoya, can you give me the equations of wave? Grace. 5 minutes. Yeah, Adekoya Olua, you're raising your hand, and can you give us the formulas?
What is this?
The equations of wave formula.
What is this? What?
The various equations.
Various equation. We have V equal to F lambda, frequency times lambda. That is the velocity for the. Are you hearing me, sir?
Yeah, I can hear you.
We have V equal to frequency times lambda. Frequency is the the time for the time, and the lambda, and the velocity is the I just noticed. And can you hear me, sir?
Yeah, I can hear you.
And we have F equal to 1/t, which is t for the time, and t for the time, and the V equal to, you can say V equal to lambda over the time. And
okay. So these are the formulas. V is equal to lambda over time, which is velocity is equal to wavelength over period, and F is equal to 1/t, or T is equal to 1/f. So these other two equations can be, this one can be, you can make T the subject because 1/f, whereas V is equal to lambda So V is equal to F lambda. So this is another equation. So you have to take note of these three very equations together with the normal equation of wave. This is the normal complete equation showing the both the vertical components and the horizontal components of the wave. You have to know them so that you'll be able to solve this problem. So I'm going to give us an assignment now. Everybody, once you do this assignment, submit to the WhatsApp group. The assignment is already here. This example, you're going to solve it. Play the video out. You're going to see how it was solved. And it was solved using these general equations of motion. So solve them, let them be very clear, send to me. Then, very importantly, the assignment, I want everybody to write, give me the definition of wave, give me the definition of frequency, amplitude, and wavelength. Then draw the diagram. If you know the diagram I showed before this one, indicating for me the crest, trough, the wavelength, amplitude, and every other thing that was indicated. Then you solve this problem and send to me, okay? Now, everybody should take note. You have barely 1 month to your JAMB exam. So you have to be more of a student. You have to always read. You have to always do stuff on your own. So please make sure that you're working. The last week of this month, we are going to concentrate on solving past questions. So we're going to solve like 5 years of past questions for each of the subjects so that we'll be able to get ready. So what I expect you to do is that after this class now, go to our what's it called? These are our JAMB WAEC. These are our Educate Africa. You see all the topics as listed here. Please, who is on that? Please, somebody should mute himself. Choma. Okay, so go through this line by line. Watch the videos, not actually the test. Use the videos. The videos are very clear and very, very descriptive. Watch all. Please, I'm talking. Somebody, I'm talking. Your ask question when I'm done talking, please. So go through them one by one. You see the dimension, unit. Yeah, somebody was asking question before the network went bad. Adekoya, are you there now?
Sir, please can you repeat the assignment?
Hi, sir.
Okay, let me repeat the assignment again. Question number one, what is wave?
Yes.
Question number two, what is wavelength? Question number three, what is amplitude? Number four, what is frequency? The characteristics of wave. Mention them with their formulas, all of them. Then draw the wave diagram indicating for me the crest, a complete circle. Indicate for me all of them. Then solve this very equation that is on this video. So write this assignment exactly the way it is and solve it. Then submit, snap your solution and submit.
Last one about characteristics or something.
Yeah, characteristics of the wave. Yeah, explain all of them to me. What is wave? Give me examples of wave, just like a summary of what we've done today. Then solve that problem and send across. And like I said, get ready for the past questions. Ending of this month, we start past questions. We'll solve it from the last week of this month. So when you're writing your JAMB, we'll just concentrate on past questions. So by then you must have gotten the concept. And the easiest way of getting the concept is by going to educateafricans.com. You click on all these topics the way they are highlighted. You just watch their videos. After watching their videos, anything I'm doing in past questions, you'll be able to understand it. Because we want to be in the spirit of past questions before the exam. So as we are finishing, as you're finishing 5 years of consistent past questions, you're very ready to start taking the exams. because with the past questions now, we can be able to summarize every other things that we've not been able to look at. So take note, make sure you're in good shape for those solvings. And the best way to be in good shape is by going to this platform, like I said, click all these one by one, watch the videos. The videos are very, very explanatory. All the things you need, they're already given there. Okay, thank you. Yeah, Adekoya, I'm still waiting for you because I want to sign up.
Sir,
Yeah.
sir, in the assignment, you want us to do the quiz here?
Yes, I
After
also
doing
want
the
to.
quiz here,
Yeah,
then we
please.
should write the characteristics of the waves, solve
Good.
the example here, and
Thank
then
you.
what else? That's
And
all.
then, yeah, that's all. Snap it and send it to my WhatsApp, to the WhatsApp group. Yeah, that's it. Okay, thank you very much. See you when I see you.